Okay, now we're going to get to where subtraction is addition. And this is where you can really see it is with rational numbers, as you will find out. Alright, so just recapping addition of rational numbers. We've already noticed that you get some subtraction relationships from addition, because when you have a vector of different directions being added together, concatenated, what ends up happening is you end up with a subtraction problem. So here is one of the situations. If s plus t star is really s minus t if s is greater than or equal to t. And of course the other situation, if t is greater than s, then s plus t star is t minus s. So if you observe the fact that subtraction of fractions becomes addition in terms of rational numbers, then for example 15/4 plus 5/3 star is the same as 15/4 minus 5/3. Well, all that is just ordinary fraction subtraction, because 15/4 is greater than 5/3. So if you turn this around and read the equality backwards, basically what you're stating is subtraction is addition. 15/4 minus 5/3 is the same as 15/4 plus the opposite or the mirror reflection of 5/3. So let's take a look at that specific example. 15/4 minus 5/3 is the same as 15/4 plus 5/3, but its mirror opposite, or its left pointing vector. So this shows that subtraction becomes the addition of two rational numbers. So if we are reading this left to right, we are saying that subtraction here is the addition of a rational number. This is rational, and because this is the mirror reflection of 5/3, it is also rational. So let's take a look at this again. In s plus t star, we have s minus t. And if we have s plus t star again, in this case t minus s if t is greater than s. So if you look at these two, you notice that the right side of the equation, so this is the right side of the equation, only makes sense in specific cases because we have to list this twice. If s is greater than t, or greater than or equal to t, that's a specific case. Or we have t is greater than s, that's another specific case. But if you look at the left side of the equation, if you notice, these are both the same, and you can put any arbitrary rational number in here at all. So that's why it makes more sense to write subtraction instead of having to test it with these conditions. Just write it as an addition problem, and you don't have to do any testing for it. It makes sense for any rational numbers, in this case s and t. So the definition of subtracting rational numbers is that for any two rational numbers, and we're going to call them x and y, x minus y is defined as x plus the mirror opposite of y. And whenever you see an equal sign with a DEF on it, that means is defined as. So it's just a shortcut for saying is defined as. So basically what we're saying is subtraction is defined as addition, and it's adding a positive with a mirror opposite, or a left pointing vector. So a right pointing vector plus a left pointing vector is the same as subtraction. So a consequence of this statement is, let's say we replace x with 0. When we do that, we get y minus 0 equals 0 minus y is equal to 0 plus the left pointing vector of y. Well, what that really means is, because 0 cancels each other out, minus y is equal to y star, which is what we've been calling the opposite reflection. Well, if that's the case, then now we can, because of subtraction, we can use the minus sign to represent the number line to the left of 0. So we have gone all the way around to getting rid of the star, because we've proven what the star is. The star is the left side, or left pointing side of the number line. But now we have proven by subtraction and addition and how they are related that minus y, and technically it should be called minus y, not negative y, but minus y is the same as y star. So let's take a look at this. If minus y is equal to y star, then that means minus y star is going to be equal to y. Remember, it's just the opposite of the opposite. So we end up with a mirror reflection of a mirror reflection, which gets us back to our right side of the number line. So now we can define subtraction, or the definition of subtraction can be restated as, if we have x minus y, then that is the same as saying x plus a minus y. So again, minus y and x plus a minus y. So from x star plus y star, we had said that we can add the two vectors together and then take its mirror opposite. Remember, this is a left pointing vector concatenated with a left pointing vector, and we get a longer length x plus y vector, but again, it's still in the opposite direction, so it is the left side. Well, now we can replace those stars with the minus sign, and we end up with minus x minus y is equal to the quantity of x plus y, but it's minus. It's on the left side. Also, we can take out the minus part of it, or the reflective, or the mirror image, however you want to term that. So if we take the opposite of minus x, we pull that out, we're left with x. If we take the opposite of y, we pull out the minus, and we are left with a minus y. So we can also say that x minus y, and take the opposite of that, is the same as saying minus x plus y. And you can try plugging that in with some numbers just to test it out. If you're not sure, then do some simple number lines with that to show that this is indeed the case. These definitions work with all rational numbers when it comes to addition and subtraction. All right, so here is our summary for subtracting rational numbers. For all fractions s and t, if we just add s plus t, the ordinary sum of fractions, we get s plus t. If we add a minus s and we subtract a t from it, you can say that we're going to add them together and then take the minus part of it, or the opposite, or the left pointing vector, whatever you want to call it. And also, if we have s minus t, that is the same as addition. So a minus t plus s, or s plus a minus t. Remember, it's commutative, so it doesn't matter. And then we can say that because if s is greater than t, we can do s minus t. If t is greater than s, we can do t minus s and then put a minus sign with it. So this is the summary of subtracting rational numbers and how they work. So practice that with some numbers on your own, and we will practice this in class and go over any confusions that you have.